Hi, Algebra 2. Today we're going to be talking about solving quadratics by factoring. You guys are all familiar with factoring, but we're going to learn a new factoring technique today, and so that would be the only new thing. But I was going to review over factoring just so that you are familiar with it again. Refresh your memory. Okay, so first let's talk about what a quadratic is. Well, typically, in standard form, a quadratic looks something like this. Ax squared plus bx plus c. And if it's an equation and we have to solve it, it's going to always have an equals, and we need it to equal 0. Okay, this is called a trinomial. Now, it can be a binomial when bx is not there, but we'll talk about that in a minute. So do you see how this has an x squared there? That tells us that we should typically have two solutions. So a quadratic has two solutions. So another word for solutions that you might hear are going to be roots and zeros. So in Algebra 1, you guys were taught how to graph quadratics. And a lot of times, most of the times, when you were graphing these, you would have them cross at your x-axis. And those would be where your solutions would be, or your zeros, or roots. You can use all three. It does not matter. They mean the same thing. So you might have also graphed like this, where it might not have crossed the x-axis, or it could have been down where it didn't cross the x-axis that way. But you weren't ever solving ones that look like this because you didn't have imaginary numbers yet. You were not familiar with them at that point. So we're going to kind of talk that through. We're not going to be graphing, we're just going to be solving, but I do want you to look and see what they look like when they might have an imaginary solution. Because they do have solutions, but they're just not crossing the x-axis to give us a real number. They give us an imaginary number. So let's talk about how we can factor. We can either, it's going to have two terms, or there's going to be three terms. We must always, the first thing that we do on either one of these is check for GCF. So we always need to check for GCF. That should be common right now. It should be something that you guys are familiar with, GCF. So we always got to look for that first. So in the two terms, it could either be a dots, which means difference of two squares. So it might look something like this. A perfect square for an x squared is a perfect square, because if you take the square root of x squared, you get x, right? And difference means it's going to be a subtraction. So you're going to have a subtraction sign. Okay, and then another perfect square, like 4. We've got to be very familiar with our perfect squares. So what are perfect squares? Anything that it multiplies by itself to give us our number. 1 times 1 is 1. 2 times 2, 4 is a perfect square. 3 times 3, 9 is a perfect square. So we need to be very familiar with our perfect squares. Okay, and the second thing that it could be is SOTs. Now this is something new for you. This means sum of two squares. This is when our imaginary numbers are going to come into play, but I'll kind of talk that through in a little bit. So now, if we have three terms, we're going to always take a GCF out. But if A is equal to 1, remember it's this A up here, this one, let me change colors right here. This A right here is this A that I'm talking about. If the coefficient is 1, your leading coefficient is 1, then we would just do our X box, which hopefully you guys are familiar with your X box. It's how we factor things. And then you would solve. And if you don't know what X box means, that just means you're trying to find factors that that multiply to your C, that add to your B. We'll talk about that in a minute too. And then you have A is greater than 1. So what if it doesn't equal 1? What if it's greater than 1? Then we have what is called a slide and divide method. This is also could be referred to as splitting the middle term. You might have done that in Algebra 1. But I prefer the method of slide and divide, and I'll teach you that tomorrow. Not today, but tomorrow. And then you would solve. Do your X box and solve. Okay, so those are the two things that you can think about. You could either needs to look at it as 2 terms or 3 terms. So before we get into actually factoring it out, let's talk about the zero product property. It states that if A times B is equal to C, then either A has to be 0 or B has to be 0 or both, because what is our multiplication says that anything times 0 is 0. So if A is 0, then we're going to get a 0. If B is 0, we're going to get a 0. And if A and B are 0, we're still going to get 0. Okay? So this property is very, very useful when we're solving quadratic equations. And we're going to talk about that in just a minute. Okay, so let's apply the zero product property real quick. So these are already factored for us. You see how we've already got them factored. So the zero product property states that I can take my first product, my first binomial, my first term, and I can set that equal to 0. And then solve. So if I added 2 over, I'd get x is equal to 2. Then it states, hey, I can do the exact same thing for my second binomial. Set it equal to 0, solve for x. So x would equal -1. So now we've got our answers, we've got our solutions, our zero, or our roots. But the way that we're going to write them as a set. So we're going to have brackets. So try to do that's how most of my brackets look. Kind of ugly. But sometimes I can get them where they not look so ugly. But try your best. So we get, the thing here is I want you to write them from least to greatest. So which one is your smallest number? -1 or 2? Hopefully everybody will tell me -1. And then you put a comma, and then you write the bigger number, 2. And do you notice that it is 2 solutions? And it's 2 solutions because if you actually went and FOILed this out, you would get x times x would give you x squared. And then something, something, something. But that 2 right there, this number right there, tells us that we're going to have 2 solutions. Okay. If you have any questions, pause, rewind, go back if you need to. All right. Number 2. So we're going to do the exact same thing here. So it's already factored for us. So we're going to take the first number, first product, first term, set it equal to 0. Then we're going to take our second one and set it equal to 0. And then we're going to solve for x. Well, 0, x equals 0 is already solved for us. So we just need to add 3 to the other side, and we get 0 and 3. So we're going to write them as a set. That one was prettier. And we're going to go from smallest to greatest. So we're going to do 0, comma, 3. And then that is your answer. Now, how do we know if we got the right answer? Well, we can always plug our terms back into our solutions. So look at this 2 right here. This x equals 0. If we plugged 0 in for that x, are we going to get a 0? Yes, because anything times 0, so 0 times whatever that other binomial would be, is going to equal 0. So it would be 0 times 0 minus 3. That would give you a -3. So 0 times -3 is going to give you 0. So that's that. And what if instead you did the 3? And if you plugged 3 in for our x, well, what is 3 minus 3? Well, it gives us 0, right? So we would have 3 times 0, which gives us 0. So no matter what, if as long as it gives us 0 on one of them, it's going to satisfy our 0 product property. Okay, last one of these. Same thing, set them both equal to 0. So 5x minus 1 equals 0. And 3x plus 5 equals 0. I'm just going to stay with a 3x plus 5 just because my pen's already in blue. So we're going to subtract over our 5. And 3x is equal to negative 5. Now we divide by 3. We get x is equal to negative 5 thirds. Now let's do it to the next one. Add over 1. So you get 5x is equal to a positive 1. Divide by 5. So x is equal to 1/5 and negative 5 thirds. So how are we going to write this? We're going to write it as a set. We're going to have negative 5 thirds first because that's smaller, and then 1/5. And then we're done. Okay, so hopefully that made sense because now we're going to go and we're going to actually factor. So we need a factor, and then we need to use the 0 product property to solve. So you have to ask yourself, 2 terms or 3 terms? Well, it looks like there's 3 terms here to me. So this is going to be a trinomial. So we're going to need to first look for a GCF. Is there a GCF in there? I don't see one. Then you need to ask yourself, because back up here we said, back at the very top, we said, is it a equal to 1 or a greater than 1? Well, down here, keep flipping back over here. Are y'all getting seasick? Sorry. So we know that a, because this is a right here, a is right there, which there's no number there, but there's an understood 1. So a is equal to 1. So we can just use our x box. So let's talk about our x box. So we have an x, and we put 36 up here because that's our c. So we need to find factors of 36 that are going to add to give me 15. So 15 goes on the bottom. So you need to ask yourself, what are factors of 36? Well, if I'm doing this, I'm like, okay, 6 times 6, that gives me 36. But does those two numbers add to give me 15? No, they don't. My next one, I'm like, okay, what about 9 and 4? That gives me 36. But those add to give you 13, not 15. So I'm like, okay, what else? What else? And then I get 12 and 3. 12 plus 3 is going to give me 15. So you have 12 and 3. Let's go and talk real quick about these signs. This sign tells me that they have to be the same sign because any number that multiplies together to give you a 36, it's either got to be a negative times a negative is going to give you a positive, or a positive times a positive, which is going to give you a positive. Then you can look at this sign that it tells you what sign it's going to be. Well, it's got to be a positive because a negative plus a negative is going to give you another negative, a bigger negative number. But a positive plus a positive will give you a bigger positive number. So now we can factor. So we have our binomial times our binomial. So we have x and x, because if x times x, we have to get us to be x squared if we FOIL that out. And here are your factors right here. I'm going to change colors. Here are your factors right here. These two numbers are what's going to go in our parentheses. Does it matter right now which one goes first? No, it doesn't. So we have 12 and 3, and we said they have to be the same sign, and they're both going to be positive, so it's going to be a plus and a plus, and set it equal to 0. Now we're going to do our product property that we've done before. So we're going to take the first one, and we're going to set it equal to 0, and solve. So we get x is equal to negative 12. And then we're going to set our second product equal to 0, and then we're going to solve. So we're going to subtract that 3 over. So we get x minus 3 equals 0. Sorry, no we don't. We get x is equal to negative 3. So we write our solutions as x is equal to negative 12 comma negative 3. All right, I'm going to stop it right now. I'm going to make another video in a second, a part 2.